Hey, welcome back to Mr. PL from Precal. This is Unit 3, Topic 1. This is lesson number 6, which we are going to be doing double angle and half angle identities. Starting off with a video of using sum and difference identity. So this is addition, which is sum. We know we're using sine, which is right here. Whenever you're doing sine, you always do exactly what you see. So it's going to be sine of the first number times cosine of the second number. And then add, because it's exactly what you see, and then cosine of the first number times sine of the second number. Now, sine of 30 is 1/2. It's in the first quadrant. Cosine of 135, remember 135 is really a 45-degree angle in the second quadrant. And so therefore cosine of 45 is square root of 2/2. And keep in mind that it's going to be negative because it's in the second quadrant. And you're going to be adding this to cosine of 30, which is square root of 3/2, times sine of 135 is square root of 2/2, because that's really sine of 45, which is positive because it's sine. Now I can multiply it, so this is going to be over 4. This is negative square root of 2 plus square root of 6/4, and there's your answer, negative square root of 2 plus square root of 6/4. All right, so if I go over here to tangent, let me move myself out of the way. Tangent of 195, I'm plugging it into here. Now keep in mind I need to separate this, sum or differences, so I need to find some sort of combination that's going to split to get this. And what I could do is change this to tan of 135 plus 60. Because remember, 135 is really a 45-degree angle in the second quadrant, and that adds up to 195. So this becomes tangent of 135 plus tangent of 60 over 1 minus tangent of 135 times tangent of 60. All right, so now I simplify. So tangent of 135 would be tangent of 45 degrees in the second quadrant, so that would be 1, but it's in the second quadrant, which means that it's negative 1. And then you're being added to tangent of 60, which is just square root of 3. And on bottom, you've got 1 minus tangent, so it's the same answer. So it's going to be negative 1 times square root of 3, which is just negative square root of 3. Minus negative becomes 1 plus square root of 3 on the bottom. And then negative 1 plus square root of 3 on top. And that's your answer. All right, so that takes care of what we did on that last video. So these are our new formulas that we're going to be using for double angle and half angle. Now, I will have some identity proving to show you where these all come from. But for the most part, I really just want to practice doing problems that are similar. So what if you have a question where you have an angle that you don't know? So that's the whole point. So let's say we have a sine of 15. Well, if you double that angle, you get 30, and 30 is something that you can do. So 30, you can find the sine and cosine and tangent of because you have those memorized. And 30 divided by 2 happens to be 15. So if you wanted to do sine of 15, you could use your half angles because you know 30. You could put 30 in for x, and then you solve for 15 because this is the formula you would use for cosine of 15 or sine of 15 or tangent. And then I do want to point out, yes, there is going to be multiples. Like you might see multiple tangent half angle formulas. You really can use any one you want. Same with this one right here. There's 2 cosine formulas, which we'll be proving. Okay, so once again, move myself out of the way. So let's say we're given this information. We're told that sine of A is 5/13. Well, you know sine is opposites over hypotenuse. So the first thing I need to do is find that third side, that adjacent side. So 5 squared plus b squared equals 13 squared. That's 169. 25. Subtract 25 from both sides, and you end up getting 144. So that for b has to be 12. So 5, 12, 13 is a Pythagorean triplet. So now I know all 3 sides. Now I can solve for both sine of 2a and cosine of 2a. So really there's 2 questions here. I'm going to solve them one at a time. Sine of 2a. So in this case, we're finding sine of 2 times a, which happens to be, remember a is this, so that equals 2 times sine of x. Sine of x will be 5/13. And then multiply that by cosine, which would be 12/13. Okay, so 5 times 12 is 60. 60 times 2 is 120. 13 times 13 is 169. So it looks like there's your answer, 120 over 169. Cosine of 2a, I'm going to use this formula right here, which is cosine squared. So cosine would be 12 over 13 squared, and then minus sine, which is 5 over 13 squared. 144 over 169 minus 25 over 169, and that's going to end up giving us a difference of, let's see, 119. I believe that's right. Hopefully the math is right. I'm going to move on. What about tangent of? So we're asked to find cosine of 2a and tangent of 2a when given tangent of 1/2. So if I make this angle A, so tangent is opposite over adjacent, so that's 1 squared plus 2 squared equals the hypotenuse squared. That's 1 plus 4, which is 5, and then square root of 5 ends up being the hypotenuse. Okay, so now that I know all three sides, now I can solve cosine of 2a. Cosine of 2x is equal to, right here, it's cosine squared, so that's adjacent over hypotenuse, 2 over square root of 5 squared, minus sine, which is 1 over square root of 5 squared. This becomes 4 over 5. 2 squared is 4, and square root of 5 squared, well, anything square root and squareds cancel each other out. And this becomes 1 over 5, and subtract, and you get 3 over 5. 3/5 is your answer. Next one would be tangent of 2x equals 2 times tangent of x, which would be 1/2. Because that's opposite over adjacent, and then over 1 minus tangent squared, which is 1/2 squared. Okay, so 2 times 1 is 2. 2 divided by 2 is 1, so the top becomes 1. And then the bottom we have 1 minus 1/2 squared is 1/4. So now we have 1 over 3/4. And then you multiply, so leave, change, and you get 4/3 as the answer. Okay, so here's these proved identities. Now, I'm already at 9 minutes and I don't have all time for this, but if you want to see how this actually correlates, because if you put the 2 over here, if you multiply both sides by 2, this is actually one of the identities for sine of double angle. And if you move this one over here, it ends up being the same thing for sine of double angle as well, cosine of double angle. If you just FOIL this, it ends up being the exact same thing as what's over there. So I'm going to leave you to looking at those on your own, but basically, those are basically the identities, and it's just proving that they work. Now, I also want to talk about half-angle identities. These are the formulas for half angles, and show you some examples of these before I finish this off. Sine of 15, so that's really the same thing as sine of 30 over 2. So I'm going to make theta 30. So I'm going to plug in 30 in for x for this equation. Now keep in mind I'm using this formula right here, which is positive or minus. Now keep in mind that you have to remember what quadrant you're in, because that'll determine basically whether or not the answer is going to be positive or negative in the end. So this is sine of 15, which means you know it's going to be positive because everything's positive in the first quadrant. So technically it's not plus or minus because the negative doesn't really make any sense. Yes, square roots do have a positive and negative, but it has to also make sense in the context of the question. All right, so this ends up being 1 minus cosine of 30 over 2. Make sure I use the right formula. Yep. Okay, so then I can change cosine of 30 because that's one of the questions that that's one of the ones they have memorized. So cosine of 30 happens to be square root of 3 over 2 and over 2. Okay, so there is going to be kind of a shortcut to doing this. Now, if you have anything over 2, I'm going to multiply this by 2 over 2. Multiply the bottom by 2 as well. Now, when I multiply this by 2, I have to multiply everything by 2, which means it's going to become positive or negative. And then this becomes a 2, and then this becomes minus square root of 3. And of course, my pen has stopped working. And then on the bottom, you have 2 times 2, which is 4. So remember, this is square root of all of this. So this can be simplified on the bottom. I'm going to have to fix my pen after I'm done with this one. And that becomes, it's positive. So it's positive 2 minus the square root of 3 and then over 2. Because the square root of 4 is 2. That can be simplified. All right, so let me fix this pen. Open the video. Okay, so we're ready for the next question, which would be tan of 195. So we want to use half angle. So the first thing I need to know is 195 times 2 is 390. So this is really the same thing as tangent of 390 over 2. So we're going to put 390 in for x into this equation. So plus or minus the square root of, this happens to be 1 minus cosine of 390 over 1 plus cosine of 390. Okay, so now keep in mind that 390 is actually a 30-degree angle in the first quadrant. So this becomes positive or negative square root of 1 minus cosine of 390 is square root of 3 over 2. And then on the bottom, you've got 1 plus square root of 3 over 2. Okay, so the first thing I'm going to do is multiply both top and bottom by 2 to get rid of those denominators. So that gives me plus or minus square root of, whoops, not 1, 2. That's going to give me 2 minus square root of 3 over 2 plus square root of 3. Okay, so there's really nothing I can do here, and there's nothing really I can do here or here. So this technically is the answer, but keep in mind that this is going to be 195 degrees, which is going to leave me in the third quadrant, and that's going to be a positive. So this is a positive answer. And there you go. Okay, so 22.5 degrees is half of 45. So this is the same thing as cosine of 45 over 2. So I'm going to be putting 45 in for x into the cosine equation, which is this one. So it's positive or negative square root of 1 plus cosine of 45 over 2. Okay, so cosine of 45 is square root of 2 over 2. Positive or negative 1 plus square root of 2 over 2 over 2. And then I'm going to multiply both top and bottom by 2. So that gives me plus or minus 2 plus square root of 2 over 4. And just the denominator can be simplified. This can't be done anything. So this becomes 2 plus square root of 2 over 2 like this. Because the bottom square root of 4 is 2. And the question now becomes, is this positive or negative? It's in the first quartile, which means it's going to be a positive. And one more example of this. So this was pi over 8. Now, that will be the same thing as cosine of pi over 4 divided by 2. Because this is multiplied by a half, and pi over 4 times 1/2 is pi over 8. So this is really a 45-degree angle, so I'm going to use the cosine equation right here. In fact, I'm just going to change this to 45 degrees for the sake of, making this a little bit simpler. So this is plus or minus 1 plus cosine of 45 over 2. And that's going to turn into plus or minus 1 plus square root of 2 over 2 over 2. And I feel like this is going to be the same question that we just had, because these are literally the same thing. All right, so I'm going to actually stop right there because it's just going to give me the exact same answer as it was in the last one. All right, thanks again for watching, and have a wonderful day.